We have answers now for A. We need to move on to B. So what I'm going to do is I'm going to copy. I'm going to go down here and I'm going to paste. The reason I like doing this in Excel so much, I mean, you might be wondering, well, geez, if StatCrunch is that easy, why do you bother? Well, for a lot of reasons. I mean, for one thing, we get questions every so often that ask us for the t-values or whatever. But also, when you copy and paste for a question like B, what does it want to know? It wants to know the same thing, still 95% and all that jazz, but with n equals 50. So I could go in here, change to 50, and look, everything else changed accordingly. Let me maximize this so you can see. All right, let me click up here in the formula. It still knows that this is x bar because I gave it dollar signs. That's why. It knows that this is s, again, because it has dollar signs. It automatically reverted to this t-value now, which we need for this problem, right? And it automatically changed to 50 because when I typed in 50, it knew to change that guy, right? So it figures everything out for us if you're smart about how you set it up, which I like. All right, so that's B. B is done. How did increasing the sample size, right? We went from 35 to 50. What did that do to us? I'll let you think about that. Those are the numbers for 35. Those are for 50. When you have 50, you know more about the data. So look at your interval. All right, I'll let you think about that. But you would type your answer in here somewhere, right? You can insert a text box, that would work too, in the insert menu. Text box right there. Let's go back. For part D, they want us to do the same thing we did for A, 99% now. Okay, so let's see. If you do this right, you can copy, go down here, paste. I'm going to label it C now. This time I want a 0.99. 35 is still in place, and since I gave S and X bar dollar signs, those are not changing at all. See? Crafty, huh? It's actually easier than going back to StatCrunch all the time and typing everything in every time. I mean, you could if you wanted to. Then they're going to want to know, you went from, in part A, you went from a 95 with 35 as your sample size to a 99 with 35 as your sample size. What happened? Right, look at the samples, excuse me, look at the confidence intervals. If you want to be more certain, 99% certain, but you still have an n that's the same size, look what happens to the confidence interval, right? All right, this is getting at a point that I think I should probably make with this tutorial. Look, there are a couple ways that you can go about making yourself more certain, making yourself more accurate. Look, if you want to be more certain you know where mu is, there's two ways you can go. You can go get a bigger sample, right? Bigger sample allows you to be more accurate, right? Smaller error, tighter interval, you're more certain, right? Well, actually, we're at the exact same level of confidence, right? But we know more about the data set, so we have a smaller confidence interval for that same 95%. The other way you can do it is you can go, right, make your confidence level bigger, that'll make your interval bigger. The problem with B is that sometimes you don't have the money to go get more people. And the problem with C is that if you make your interval too big, then it's kind of useless. You know, like for example, I know that President Obama's approval rating is somewhere between 10% and 90%. I'm really, 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 really certain of it, but it's kind of pointless, right? Because, you know, yeah, of course it's between 10 and 90. I mean, can't you be a little more accurate than that? So you can gain accuracy by going and get more people. You can gain confidence, right, by just making a bigger interval. They each have their downsides, right? So it's just a question of what you're willing to live with as a statistician. All right, so that I'm giving you some hints, right? I didn't quite tell you what to do, but giving you some hints for what to write up for B and C, right? How your confidence level is affected, right? If you up it, what happens to your error, right? How off you are, how big your interval is. And if you boost how many people you go get, how off is your error, right? Your error is how wide your interval is. It's actually half as wide as your interval. Right, so when they're talking about that, they're talking about, look, how far apart are the lower and upper limits? Are they far apart or not far apart? Right? Are they accurate, meaning they're close together, or not accurate, meaning they're far, far apart from each other? All right, I think we're good for that. See you for the